Hello everyone, welcome to your first lesson in geometry. We are in the standard GCO1, which is all about geometric vocabulary and an intro to geometry. Now, if you happen to lose your notes packets or any worksheets within this standard, you would go to my Canvas site and click on modules. And underneath module 1, I have the GCO1 extra notes copy right here for you. Here's the Ed puzzles. I have extra worksheets, and then also when you complete the worksheets, there's an answer key here that you can check. And then I also have an extra review packet, and then we already talked about having that retake practice. So just a rundown of what is in this section of GCO1. It contains the notes, the Ed puzzles, the worksheets with answers, and the review packet and the retake practice. All right, let's dive in. So we are going to be just strictly talking about vocabulary words of geometry. And now, much of geometry was developed as Euclidean geometry by a Greek mathematician, Euclid. And Euclid's most important work was the 13 volumes of the Elements of Geometry, which Euclid began his system of geometry with 3 undefined terms. Those 3 undefined terms were points, lines, and planes. And we will informally define them because they are undefined terms. Undefined terms is more of like an abstract concept. It means that these terms are not formally defined, and they can be used to define other concepts. So after Euclid began his system with these 3 undefined terms, he then started to define other geometric vocabulary. He also started to create postulates and axioms. Postulates and axioms are just straight up facts in math. These are things that would not need to be proved. For example, a postulate could be something like this. I have 2 points, and I know that there's only one line that could connect those 2 points together. That would be an example of a mathematical fact. And after Euclid developed postulates and axioms, he then used the definitions of postulates, or used definitions and postulates to prove mathematical theorems, which some of you guys may remember. The most famous theorem that we have talked about already in algebra is the Pythagorean theorem. Now there's many proofs of the Pythagorean theorem. However, theorems are things that need to be proved. And what that means is that they weren't accepted to be true, that people or mathematicians actually had to go through the process of proving that they were correct on their theorem that they created. And we'll be proving theorems this year as well. All right, so now we're going to get to some geometric vocabulary. So with this, we have definitions that I gave you guys, and then we're going to come up with a word. So a statement based on known information that is believed to be true but not yet proven. This is called a conjecture. And on your notes, you don't have this picture box. I don't know on my notes why I have that, but ignore that column for this. All right. So a conjecture is something that you believe to be true based on information that you know, but it's not yet proven to be true, so it's just a hypothesis. Next, a rule that is accepted as true without proof. That is a postulate. A rule that can and must be proven to be true. That is a theorem. Whoops, I missed it. Theorem can also be abbreviated as THM. So if you see that, that would also mean theorem. A specific case that shows a conjecture false. That is a counter example. All right, moving on. So we're going to talk now more about those undefined terms. Undefined terms, the points, lines, and planes, are the most basic figures in geometry. They're not formally defined. They are abstract. These terms can be used to define other geometric terms and properties. And when I say abstract, I'll talk about what that means in a moment. But this word names an object or location in space and has no actual size. This is a point. And so a picture would look something like this, where you have just a dot on paper. And then we normally for a point, you would see a letter, a capital letter underneath it. And then to label it, you could say point A, or you can just use A. However, it needs to be a capital letter. Now, the reason why I say that a point is an abstract concept is because it says that it names an object or location in space and has no actual size. For example, a city on a map could be considered a point, and we use a point to represent it on the map. However, the city of Chicago and the city of Cincinnati, they are not the same sizes. They are actually quite different. So, but we use the same type of symbol to represent those things. So that is what I mean by it's abstract, but it doesn't even have to represent a city on a map. A point could be a star in the sky. Points can be a lot of different things, as long as you are saying that your object, a point names an object or a location in space. That's it. All right. And then a line is a straight path that has no thickness and extends forever. So here would be an example of a picture of a line where you have two arrows on the end, and it's a straight line. And now what we do is we name a line with 2 points. So you can name this line AB. You can also name this line BA. Whoops. A line is typically named with any 2, that's key, points on the line. And remember, points are named with capital letters, so there should be no lowercase letters when we're talking about points. However, there's another way to name a line. Sometimes you may see a little italicized lowercase letter on one side of your line, and it doesn't matter which line. I am terrible at drawing italicized letters, so I'm going to draw just like a cursive L here. So, or you can name this line L, or just L. That stands for line L. So you can name it using a lowercase italicized letter. Now, again, this is an abstract concept because it says that it has no thickness and extends forever. And this extends forever part is when we're talking about objects or lines in the real world. They don't necessarily extend forever and ever. An example of a line in the real world would be something like a road or a ruler. All right, while this doesn't extend forever and ever, it's still considered a line, and those have no thickness or no set thickness to it. For example, a road is not the same width as a ruler, so that's what I mean by has no thickness. All right, and then lastly, a plane, and we're not talking about an airplane. We are talking about a two-dimensional flat surface that extends forever. And again, in the real world, it's not going to go on forever and ever. But in geometry, it does. So a picture of a plane, we draw kind of like a parallelogram looking thing. And when we name a plane, you would use any 3 points within your plane. And it doesn't matter the order. So this could be plane ABC, plane BCA, plane CBA, and so forth, but it's just named with any 3 points on the plane. But just like with a line, it does have another name, or can have a number name. So this could also be called plane L. It can be labeled with a capital script letter. A plane could be something like a desk or a wall or the floor. So that's what a plane would be, and it's undefined because a desk, a wall, the floor are not the same size. All right, the set of all points that lie in the same line, that is collinear. And the set of all points that lie in the same plane, that is coplanar. Collinear would be something like this. You have multiple points lying in the same line. And you would say points A, B, C, and D are collinear. And coplanar would be something like this, where we have multiple points lying in the same plane. And you would say points A, B, and C, and D are coplanar. All right, part of a line consisting of 2 endpoints and all the points in between. This is a line segment. We'll talk about the picture and notation in a moment, and probably in a new video. Part of a line that starts at 1 point and extends forever in one direction. This is a ray. 2 rays that have a common endpoint and form a straight line. This is opposite rays. 2 or more segments with the same length. This is congruent segments. and then we will continue this lesson in a new video.